Hello, my name is Hugo Vives, and for the past year I have been developing a research project about the physics of vibration down slopes. My initial inspiration for this project came when I first saw a mobile phone vibrating on a slightly inclined table and it moving around. This caused me to wonder what the physics behind this phenomenon might be. Since I have a great eagerness for investigating in physics and understanding both the theoretical and the practical framework which I am working with, I began to investigate with this project to understand why this vibration causes linear motion. As an initial hypothesis, I proposed that perhaps the velocity of the object moving down the slope could be proportional to its frequency, since intuition and observation showed that as the vibration was faster, the object would also move faster down the plane. I ended up using this small motor I found within my school supplies, along with a 3D printed eccentric rotating mass. An eccentric rotating mass has an offset center of mass, which allows it to increase the vibration of the motor it is attached to and make them more noticeable so that I could measure vibration more effectively and make the results of my experiment more reliable. Moreover, I used these string rails in order to direct the motor and ensure it had linear motion down the slope, since in my pre-tests, when I was testing it on a uniform slope, it moved from side to side instead of linearly downwards, which would invalidate the results of my experiment. The independent variable in my experiment was the frequency of vibration of the motor, which I could change in order to figure out how it affected the dependent variable. The dependent variable, what I was measuring, was, in this case, the velocity of the motor down the slope. In order to make sure my results were more reliable, I had 3 trials for each of the 9 frequencies that I was measuring. This gave me 27 total trials and many more data points which I could later analyze to make sure there were any trends that were appearing. In order to measure my data, what I did was take a video of each trial with a timer and a measuring tape on camera. This allowed me to use the time and the position of the motor at each point in order to figure out the total velocity and then compare it with the independent variable, which was the frequency. Furthermore, I also performed a mathematical model approaching the problem of vibration through the modeling of forces, like I had learned in my physics and math lessons. This allowed me to compare the empirical results from my practical experiment to the theoretical framework that I had established, and I also plotted graphs that compared the empirical and theoretical results to see how they were similar and in what ways they were different. As a conclusion, I found that the frequency of vibration of a motor moving down a slope does indeed affect its velocity moving downwards. Even though the mathematical analysis did not exhibit a perfectly linear relationship, the overall relationship between both models and what I had found in my experiment seemed to show that the relationship between the frequency and velocity was indeed linear, and there was a direct relationship between them. This confirmed my hypothesis and solved my initial question of why my phone was moving when it vibrated on an inclined table. These results have some interesting applications in the industry and other similar physical systems, which is related to the UN Development Goal number 9, Industry, Innovation and Infrastructure. An example of a system which could use vibrational technology instead of traditional linear movement is the use of conveyor belts. Conveyor belts are used in factories with linear movement in order to transport resources through it. However, if instead of moving linearly, it would vibrate, it could expend much less energy and the resources could still move around the factory. This would set a framework for a more sustainable mode of manufacturing and transporting goods, which is extremely useful and would be very beneficial in our current energy crisis.